In this video, I'll show you how to set up Z-stack imaging and tile scans across multi-wells, including how to choose and apply a focus strategy. In this experiment, I'm imaging live cells with 4 fluorophores plus bright field. I'll be imaging only the bottom half of the plate. You can see all available channels listed at the top. To find focus, I'm using the DAPI signal. I'll turn off the display of the other channels by unchecking these boxes. This affects display only, not acquisition. I'll change the DAPI pseudo color to cyan, turn live off and back on, and adjust the focal plane by scrolling the mouse wheel over the Z range. The focus looks good. Next, I'll set up a tile scan in each well. Click Well Coverage. To create a tile scan, select the mosaic. You can either enter the number of rows and columns, or use fill factor and enter a fraction of 1 to define how much of each well is covered. You can image multiple positions per well. These positions can either be random in each well or identical across all wells. If your cells are concentrated near the edge or center of the well, you can adjust the position placement using the slider. I'll image a 2x1 tile in each well. Click this button to confirm tile placement across the plate. Click here to return to the current position and double-click to move the stage. Each tile scan now appears in the task list. With just a few clicks, 48 tile scans have been created. Once tiles or positions are set, go to Experimental Settings and activate focusing. I'll use image-based autofocus with the DAPI channel. This is a software-based autofocus that acquires a Z-stack at a defined position and selects the Z-plane with the highest contrast. I'll apply autofocus every 6th position, which corresponds to the first tile in every 3rd well. Now I'll set up Z-stack imaging. Under the experimental setting, click 3D imaging. There are 2 ways to define Z-stack. 1. Manually move through Z and mark the beginning and end position using the same button. 2. Stay at the center focus plane and click the cogwheel icon to open the 3D imaging settings. I'll use a second method. Here I'll enter a Z-stack thickness of 60 micrometer. The software automatically calculates the optimized Z-step size based on the objective. If you want to override this, select either number of steps or Z-step size and enter your values manually. I'll use 5 steps in total. Next, I'll scroll through the Z-stack to confirm it covers the correct range. If the stack is off-center, you can refocus and click Recenter Z-stack. Now I'll turn the other channels back on for display. Since I want both fluorescence and bright field, I'll enable TL for acquisition. In the transmitted light sequence, I'll select Live and click One Touch. One Touch already has run for fluorescence. If it hasn't, you'll need to click Live under Fluorescence Settings and run One Touch there as well. Everything is set. Transmitted light on, fluorescence on, 3D imaging configured, stage positions and tiles are defined, autofocus enabled, environment on, indicating the incubator is active. Everything looks good. Click Start to begin acquisition. Click this button to view the imaging positions live. The acquisition is complete. Click Results to view the images. Select an image, turn on all channels including bright field, and scroll through the Z-stack. Everything looks good. Now you're ready to image Z-stack tile scans in every well.
If you have any questions or want to learn more, please reach out to us via the link in the description or scan the QR code on your screen. Thank you.